Hello everyone, welcome to Brain Blitz Audios. Today, in this episode of NEET Preparation, we'll be dealing with previous year questions of physics and medical entrance examinations in India. Today, we'll be dealing with the chapter Motion in a Straight Line. This is a very important chapter, and this is the second chapter in the grade 11 syllabus for physics in CBSE. So, this chapter is very important, and therefore the questions here are also super important. Let's look at our first question. A ball is thrown upwards. Its height varies with time as follows. This graph. If the acceleration due to gravity is 7.5 meters per second square, then the height h is A 10 meters, B 15 meters, C 20 meters, D 25 meters. So, how do we start solving this question? We need to find the average time it takes to reach the maximum height. So this time will be T average of the total. So the maximum time is 6 plus minimum time is 1 second divided by 2. That gives you 3.5 seconds as T average. So we found out T average. And we know that the value of G is 7.5 meters per second square. Now, in this question, we know that the motion that is undergone is vertical motion, and in vertical motion, the velocity at the highest point must be 0. So here V is equal to 0. So using the first equation of motion, we know that 0 is equal to U minus AT. We take AT to the left-hand side, to the other side, so we get the relation U is equal to A times T. Multiplying A and T together, here A is equal to G is equal to 7.5 meters per second square. So that is 7.5 into 3.5. We'll just do 75 times 35. 5 times 5 is 25. 7 times 5 is 35. 35 plus 2, 37. And 5 times 3 is 15. 7 times 3 is 21. 21 plus 1, 22. And now we get 2625. So we get 26.25 meters per second as the value of the initial velocity U. So now we need to find the height h. If you notice the height h, it is the difference of height of the position of the object between the first and the second. So how do we solve this question? First thing we do is we find the position of the object using the second equation of motion at the time 1 second and 2 seconds. So y, which is the position at 1 second, is equal to, using the second equation, it'll be u times the time is equal to 1 plus minus a times half times t square. T square is 1 square. So it'll be u minus half into 7.5 into 1. So basically it is, we know the value of u is 26.25 minus 7.5 by 2. 75 by 2 is 37.5. So we get 26.25 minus 3.75. And when we do that, 2625 minus 375, 5 minus 5 is 0, 12 minus 7 is 5, 5 minus 3 is 2, and then there's a 2. So we get 22.5 meters as the value of the position of the object at 1 second. The position of the object at t is equal to 2 seconds will be equal to u times 2 minus half into the value of a is 7.5 times 2 squared. So it will be 2 times 26.25 minus half into 7.5 times 4. So 2 goes into 4 2 times. So basically we have 2 times of 26.25 minus 7.5 because both have 2 as common. So I took 2 common out. So we got the value of 2625 minus 750 as 18.75. So it is 2 times 18.75. So when we multiply that, so that is 1875 times 2. So 5 2s are 10, 7 2s are 14, 14 plus 1 is 15, 8 2s are 16, 16 plus 1 is 17, 1 2s are 2, 2 plus 1 is 3. So we got the value of y at 2 seconds as 37.5 meters. And we know that the height h is equal to y at t is equal to 2 seconds minus y at t is equal to 1 second. So therefore, it'll be 37.5 minus 22.5. Just do simple subtraction. 375 minus 225. 5 minus 5 is 0. 7 minus 2 is 5. 3 minus 2 is 1. So we get the value as 15.0 meters. So the height is 15 meters. And which of these options gives you 15 meters? Option B. So the right answer is option B. We found that by finding out the average time and using the second equation of motion to find out the position of the object at 2 different time periods, and then subtracting them in order to find the height between them. And that height is equal to 15 meters. Let's move on to the second question. The coordinates of a moving particle at any time t are given by x is equal to at squared and y is equal to bt squared. The speed of this particle is. So we know that x is equal to yt squared and x is equal to at squared and y is equal to bt squared. So obviously, this question requires us to do a little bit of differentiation. But how do we differentiate it? The vector r, which is the position vector, can be written as at squared I cap plus bt squared j cap. Because in our question, the x coordinate is given as at squared and the y coordinate is given as bt squared. I cap represents the unit vector along the x-axis, j cap represents the unit vector along the y-axis. So this is how we represent each coordinate in the given position vector. Now what we do is we differentiate with respect to t. When we differentiate this vector with respect to t, that is dr bar by dt, it gives you the value of the velocity vector v. So it will be a times dt squared by dt I cap plus b times dt squared by dt j cap. Now the differential of t squared with respect to t is equal to 2t. So a times 2t I cap plus b times 2t j cap. So the velocity vector can be written as 2at I cap plus 2bt j cap. Now over here, we got the expression for the velocity vector. So this gives us the velocity when we put the appropriate values of a, b, and t. A and b are constants here. However, the question is asking us to find the speed of the particle. So we know that speed is a scalar quantity while velocity is a vector quantity. And that speed is equal to the magnitude of vector v. So that is modulus of vector v. So the value of speed is equal to the value of modulus of vector v. So let's find that out. The modulus of the velocity vector, which is its magnitude, will be equal to the sum of the square of the individual components, which is given under a big root. So that means the x component, 2at the whole square, plus the y component, 2bt the whole square, and that is given under a root. On solving it, we know that 2at the whole square will be equal to 4, because 2 square is 4. Then there is a square, and then there is t square. Similarly, in the y component, 2 square becomes 4, then it becomes b square, and then t square. So 4a square t square plus 4b square t square, the whole root. Now inside the root, we can take 4t square as common. So 4t square times a square plus b square. So 4t square is taken common, and all of that is inside the root again. Now we notice that the square root of 4 is 2, and the square root of t square is t. So we can write the magnitude of the velocity vector as 2t into a square plus b square, the whole root. So what we did was we took 2t outside the root, because the value of 4t square, the whole root, will give you 2t, and then a square plus b square is kept under a root. So this is the expression of the speed of the particle. And if you look at our question, you find that option B is the right option. It gives us the same value. So what did we do here? Using the two components given, we found out the position vector. We differentiated it to get the velocity vector. And once we got the velocity vector, all we had to do was find its magnitude in order to get the speed of the particle. And the speed of the particle is 2t times root of a square plus b square. Let's move on to the third question. A body starts from rest at time t is equal to 0. The acceleration time graph is shown in the figure. We need to find the maximum velocity attained by the body. So over here, we know that the graph given is an acceleration time graph. So in an acceleration time graph, the area given under the graph is equal to Vf minus Vi, final velocity minus initial velocity. So the area under graph represents the change in velocity, delta V, and delta V is equal to Vf minus Vi. In this question, it says that a body starts from rest. So that means the initial velocity is equal to 0, and that starts at time t is equal to 0. So in order to find the maximum velocity, after putting in the value of Vi, we know that area under graph is equal to Vf minus 0, which is equal to Vf, that is the final velocity. And the final velocity is Vmax, the maximum velocity. So to find Vmax, we just need to find the area of the triangle. And why do I say a triangle? Because the x-axis, the y-axis, and the linear graph given gives you a triangle, a right-angled triangle. So if we find the area of this triangle, we can find out the area under the graph, which is Vmax. And what is the formula for area of a triangle? It is half into base into height. Over here, the base is 11, so half times 11, and times the height is 10. So 2 goes into 10 5 times, so we get 5 times 11 equal to 55 meters per second as the maximum velocity attained by the body with this acceleration time graph. So option B, 55 meters per second, is the right option. Let's move on to the next question. Two bodies begin a free fall from the same height at a time interval of capital N seconds. If vertical separation between the two bodies is 1 after small n seconds from the start of the first body, then small n is equal to. We need to find the value of small n. So to give you a gist of the question, let's look at the scenario. A body 1 is thrown and it reaches a distance, say d, after n seconds, capital N seconds. Now at this position, a second body is thrown, it's dropped from the height. Now what happens is, after small n seconds of the dropping of the first body, we need to find, we know that the distance between the second body and the first body will be equal to 1. And we need to find out the value of lowercase n. So first, we need to find the position of both bodies after small n seconds. So let's consider y1 as the position of the first body after n seconds. So that will be equal to, and here we use the formula S is equal to ut plus half AD squared, which is the second equation of motion. So here u, the initial velocity, is 0 because the bodies begin a free fall. So they're dropped. So 0 times, we don't know the value of time, but however, we know that it's given as the value n. We know that the variable small n is used for the time because this is the first body. And then, since g is acting downwards, and the motion of the body is also downwards, we take g as positive. So 0 times n plus half into g into t squared. Here t squared becomes n squared. So the value of y1 is equal to half g small n squared. However, for the object y2, the body y2 is dropped after capital N seconds. So if at small n seconds, the body 1 reaches some place, then the time interval of the second object at that point would actually be small n minus capital N, because it is dropped at a later time. So that time interval is subtracted from the original time interval of the first body. So in order to make the matter clear, let's write it down. So y2 is the position of the body after n seconds of dropping the first body. So u is again 0. However, the time period will be small n minus capital N, because there is a time interval of capital N before the second body is dropped. And here again, g is positive, plus half into g into t squared becomes small n minus capital N the whole square. So y2 is equal to half g into small n minus capital N the whole square. So we know the value of y1 and y2. In our question, it is given that the value of y1 minus y2 is equal to 1. Vertical separation between the two bodies is 1 after n second. And that's why we took the time period of n second in order to get this vertical separation as 1. So the difference between the position of the first body and the position of the second body, which is termed as vertical separation, is equal to 1. So therefore, let's put in the values. So half g small n square minus half g small n minus capital N the whole square is equal to 1. We can take half g as common, so half g into small n square minus small n minus capital N the whole square is equal to 1. Now notice the inside the large brackets, we have something that is similar to this, a square minus b square. So this is an algebraic identity, and we take the right-hand side. That is a plus b into a minus b. So we now use this identity inside the brackets. So it will be half small g, and then inside the bracket, the first term will be n plus n minus capital N, and then multiplied by n minus small n minus capital N. Is equal to 1. Now we solve each of the smaller brackets. So small n plus small n minus capital N will give you 2 into small n minus capital N in one bracket. In the other bracket, small n and small n gets cancelled, and we have capital N, positive capital N, on the other bracket. And that is equal to 1. So g by 2 into 2 into small n minus capital N times minus capital N is equal to 1. Now how do we solve this question? We take g by 2 to the other side. So 2 into small n minus capital N times capital N is equal to 2 by g. G by 2 taken to the right-hand side will become 1 by g by 2, that is 2 by g. So now what do we do? Let's take this capital N to the right-hand side. So it'll be 2 into small n minus capital N is equal to 2 by g into capital N. Because it's in the numerator here, it goes down to the denominator in the right-hand side. Now, let's plug in the value. Instead of plugging the value, let's put this minus n to the right-hand side. So it becomes plus n. 2 into small n is equal to 2 by g times capital N plus capital N. And taking the LCM on both sides, we get 2 plus g capital N squared divided by g capital N. What we did was we multiplied the denominator g capital N to the numerator capital N, so we got g capital N squared. So this is the value of 2n. We need to find the value of small n. So what do? We just take to the right-hand side. So n is equal to 2 plus g capital N squared divided by 2g capital N. Now we can split the two terms, so it'll be 2 by 2g capital N plus gn squared by 2g capital N. And we can cancel 2 on this side, we can cancel g on this side, we can cancel one of the n's from this side. So we get 1 by g capital N plus capital N by 2 as the value of small n. And this equation is the same equation as is found in option C. So after solving the question using the second equation of motion, we found the value of small n as 1 by g capital N plus capital N by 2. Option C is the right option. Now let's move on to the final question of this episode. From a balloon moving upwards with a velocity of 12 meters per second, a packet is released when it is at a height of 65 meters from the ground. The time taken by it to reach the ground is, and the value of g is given as 10 meters per second squared. So suppose this is a balloon and we're dropping an object from the balloon. So this will have an acceleration g. However, in this question, we're taking the velocity of the balloon, which is u, that is 12 meters per second, as positive. So when upwards is taken as positive, downwards will be taken as negative. So g will be negative, and also the distance that the balloon had already covered, which is h, is equal to 65, will be equal to minus 65 meters, because h will also be negative. The object has to travel negative distance in order to reach the ground, and it also has negative acceleration. The reason why both of these are negative is because we considered the upward direction as positive, so that our velocity becomes positive. So having said that, we know that u is positive, g is negative, also s is negative. So we've dropped this object from a balloon to the ground. We need to find the time taken by it to reach the ground. So the time taken by it to travel minus 65 meters. So what do? We use the second equation of motion. This is s is equal to ut plus half at squared. The value of s, which is equal to vertical distance, that is height, will be equal to minus 65. And the value of u, which will be positive, is 12. So 12 times t, because we don't know the value of t. That is the variable. And then since g is negative, we take the second term as minus half into the value of g is 10 times t squared. So minus 65 is equal to 12t minus 5t squared. We can write this equation as 5t squared minus 12t minus 65 is equal to 0. So now we've converted that equation into a quadratic equation of the form ax squared plus bx plus c is equal to 0. Now we've turned this equation into a quadratic equation. We need to solve this quadratic equation. Now, it's pretty difficult to use the other methods such as prime factorization to solve this. So therefore, we'll use the quadratic formula because there is no prime factors that we could find. So use the quadratic formula. And what is the quadratic formula? The variable x will be equal to minus b plus or minus root of b squared minus 4ac divided by 2a. Here our variable is the time t. Minus b will be equal to minus of minus 12 plus or minus, in the under root, we get b squared minus 4ac. So b squared will be minus 12 the whole square minus 4 times 5 times minus 65, and then divided by 2 times 5. Now notice that we are taking the signs here according to this equation. 5t squared minus 12t minus 65 is equal to 0. So minus of minus 12 becomes plus 12, plus or minus. Minus 12 squared is equal to 12 squared is equal to 144. And then 4 times 5 is 20. And when we multiply 65 by 20, we'll get 0, 0. 5 times 2 is 10. 6 times 2 is 12. 12 plus 1 is 13. So we get 1,300 as the value of 4ac. And since there is a minus 65 and there is a minus 4, this 4ac will be plus. So plus 1300. and both of that is inside the root, divided by 2 times 5 is 10. So on adding these, we'll get 12 plus or minus root of 1444 divided by 10. How do we solve from now on? Now notice that the number 1444 is close to 1600, and 1600 is the square of 40. Also notice that when we square the number 8, we get the value of 64. So from here, we can guess that we should use 38 to divide 1444. So that 38 will be the square root of this number. Let's test our hypothesis. 38 times 38. 8 times 8 is 64. 3 times 8 is 24. 24 plus 6 is 30. 8 times 3 is 24. 3 times 3 is 9. 9 plus 2 is 11. That becomes 4, 4, 4, and 1. Voila, we got our answer. So we know that 1444 is the square of 38. So the square root of 1444 will be equal to 38. So it will be 12 plus or minus 38 divided by 10. So that means we'll have two values of t. So t will be equal to 12 plus 38 divided by 10, or 12 minus 38 divided by 10. Since we need to find the numerical value, we'll have to solve this. 12 plus 38 will give you 50, 50 times 10, or 12 minus 38. Let's do it. 38 minus 12, and then we'll put the negative sign on it. 8 minus 2 is 6, 3 minus 1 is 2. Put a negative sign, so we'll get the value of 12 minus 38 as minus 26 by 10. So dividing by 10, so t will be equal to 5 seconds, or minus 2.6 seconds. But you'll immediately recall that time is a scalar quantity, not a vector quantity. That means there is no negative value of time. So therefore, we can eliminate minus 2.6. So the value of t will always be equal to 5 seconds in this scenario. Even after using the quadratic formula, we have reached the right answer. So therefore, time is equal to 5 seconds. And which of these options gives you the answer as 5 seconds? Option A. So after calculating our answer using the second equation of motion, appropriate signs, and the quadratic formula, we got the time taken by an object dropped from a balloon to reach the ground as 5 seconds for the given scenario. And that concludes this episode of NEET preparation. So the chapter motion in a straight line is very extensive, and it has a lot of questions in NEET exams. So therefore, we've done a couple of other episodes of the chapter as well. Please don't forget to click on the links of that playlist in the description down below and access all our other videos. In order to get more of our useful and interesting content, such as learner words, mind maps, memory hacks, English lessons, etc., please subscribe to our channel, Brain Blitz Audios. You can also hit that bell icon, which is the notifications button down below, in order to receive the latest notifications about our content. So until the next episode, take care, stay safe, bye-bye for now.